And good morning, fourth grade students. Time for a little bit of Eureka math here in room 502. Get out your homework, please. If you didn't do it, you can still get it out and follow along. Make sure your name is up here. Homework was page 11. Today's date, I believe it's the 17th already. So our example was 5 times 10. 5 ones times 10 equals 5 tens. There's our 5 ones. Boom. Times 10, we got 5 tens. Let's continue down here. Excuse me. It says, draw a place value disk and arrows is shown to represent each product. 7 times 100. Let's put our 7s right here. 1, 2, 3, 4, 5, 6, 7. We're multiplying by 100. So what do we have over here? Looks like we have 700s. So 7 times 10 times 10. I know 10 times 10 is 100. 7 times 10 times 10 is 700. And 7 ones times 10 would be, 7 ones times 100 is 7 hundredths. Bingo. We'll continue on. 7 times 1,000. Here's my 7 ones. Excuse me. And we're going to times it by 1,000. That means we go over 3 columns. What do we have? We have 7,000s, right? So 7 times 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. 7 times 1,000 is indeed 7,000. And 7 ones times 1,000 is 7 thousands. And there we have it. Okay, we're going to fill in the blanks in the following equations. 8 times 10, 80. Something times 8 equals 800. That would be 100 times 8 equals 100. 8,000 equals 8 times 1,000. We'll continue on. 10 times 3 is 30. 3 times a number equals 3,000. Of course, that would be 1,000. And blank times 3 equals 300. That would be 100 times 3. Let's switch colors here. I don't know if this one's showing up too well. Go with green. 1,000 times 4 simply is 4,000. Something is equals 10 times 4. That would be 40 equals 10 times 4. And 400 equals what times 100? Well, that would be 4 times 100. Flip her over. Okay, they're asking us to draw a place value disk and arrows to represent each product. 15 times 10. Getting a little tricky here, okay? So let's see what we got going. 15 times 10. I have 1 10 and 5 ones. Do we see how that's 15? We're multiplying them by 10. What are we left with? 1, 5, and 0. So 1, 10, 5 ones, right? Times 10. We have 1, 10, and 5 ones equals 150. Let's try 17 times 100. 17 is 110. 7 ones. And we're multiplying by 100. So 10, 100. Watch what happens. Excuse me. So 10 times 100 is 1,000, right? And then we have these 7. We're multiplying by 100. So those 7 ones become 7 hundredths. And what are we left with? 1, 7, 0, 0. So 17 times 100 is 1,700. Same thing here. 17 times 10 is 170. 170 times 10 would be 1,700. 110, 7 ones times 100. Think about it. 110 times 100 is 1,000. 7 ones times 100 is 700. And we're done. Okay, we're getting into the 10,000s. We have 36 times 1,000. So let's do 3 tens and 6 ones. Multiplying by 1,000. Okay, that means 3 over. 1, 2, 3. And so we have 30,000, right? 30 times 1,000 is 30,000s, right? And then we have these 6, because it's 36 times 1,000, so 6 times 1,000 is indeed 6,000. So it's 36000. So 36 times 1,000, think of it. 36 times 1 would be 36, and then we just add on the 1,000. 36 times 10 times 10 times 10 is just 36 times 1,000. 10 times 10 is 100. 100 times 10 is 1,000, so it's 36,000. And 3 tens and 6 ones times 1,000. 3 tens times 1,000 is 30,000s, right? 3 tens, and then 6 tens times 1s, 1,000 is 6,000, so once again, 36,000. Okay, they're asking us, the fine folks at Eureka, to decompose each multiple of 10, 100, or 1,000 before multiplying. So we're decomposing. Excuse me, 2 times 80 equals 2 times 8 times what? Well, 8 times 10 is 80, right? So we have 2 times 8 is 16 times 10. 16 times 10, would be 160. Let's go on to number 8. 2 times 400 equals 2 times 4 times 100. 2 times 4 is 8. We just do drop down the 100, so now it's 8 times 100, easy enough, 800. Let's go to 5 times 5,000, equals 5 times 5, right, times 1,000. And we know 5 times 5 is 5, 10, 15, 20, 25. So we're just at 25 times 1,000 equals 25,000. There we have it. 7 times 6,000, we just do the 7 times 6 and then 1,000, right? 7 times 6 and add on the 1,000, multiply it. 7 times 6 is 42 times 1,000, and we get 42,000. Go ahead and put your homework in the homework drawer. We're going to move on to our concept development. See what special guests we have coming out today. I can't wait. So get to this chart right here. And we're first going to start off with 2 ones times 4. All right, so let's write 2 ones times 4. Okay, so 2 ones times 4. There's 2. There's 4. There's 6. And there is 8. So that's 2 ones times 4. Now let's take a look at 2 tens. 2 tens times 4. This would be 8, right? 2 ones times 4 is 8. 2 tens times 4. There's 10, 20, 30, 40, 50, 60, 70, 80. So 2 tens times 4 would be 80, right? 10, 20, 30, 40, 50, 60, 70, 80. Now, we're going to go to 2 hundredths. 2 hundredths times 4. What do we think it's going to be? 2 hundredths times 4. Well, I know 2 times 4 is 8. We're multiplying by 100, so 2 times 4 times 100. But it sounds like it's going to be 800. There's 200, 400, 600, and last but not least, 800. Ta-da! Let's continue on to our next page. And your pages are in the back. I have the master copies. And let's go on to, we're going to do, let's do 8. Excuse me. Go down here in our blank piece of paper, our blank area. We're going to write 8 times 2 ones equals 16 ones. Write that down, please. 8 times 2 tens equals what? 16 tens. 8 times 2 hundredths equals 16 hundredths. And 8 times 2 thousands equals 16 thousands. All right, let's demonstrate that, okay? Let's do the 8 times 2 hundredths, okay? Go ahead and finish writing that down. You might want to freeze frame. And we'll go to 8 times 2 hundredths, okay? So 8 times 2, 16, right? So let's do this, but 8 times 2 hundredths, okay? 1, 2, 3, 4, 5, 6, 7, 8. That's 8 times 100, but we're multiplying by 8 times 200s. So what do we get? 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100, 1,200, 1,300, 1,400, 1,500, 1,600 are 1,600. So in essence, we could take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and make 1,000. So we would have 1,600, or 1,000, excuse me, or 1,600s. Just like we said down here. Right? So, let's take another look at this, and we'll do the same problem. We're going to mix it up a little bit. 8 hundredths times 2. So we have 8 hundredths times 2. Let's do 800. There's 800, and now times 2. Same thing, right? We could take 10 of those and bring them over here. We could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 1,600, so 1,600. And we're going to move right along to, let's turn over. We got a few extras, I believe, of the place value charts. We're going to go right here to Francisco. You know what? Since we do have a few extras, let's head back and do one more. And we're going to go like this. Come on down here, and we'll say 5 times 2 ones equals what? 10 ones. 5 times 2 tens, and write this down please, equals 10 tens. 5 times 2 hundredths equals 10 hundredths, and 5 times, please write this down so you get this down, 2 thousands equals 10 thousands, okay? So, just like the one before, but let's diagram it now. Let's go over to our place value chart, go up, you could always pause that so you have time to write it down, and I'll welcome back if you did pause. And we're gonna do, just like we did with the last one, we'll do, let's say, let's do 5 times 2 hundredths. 5 times 2 hundredths. Okay, so 5 times 2 hundredths, there's 2 hundredths one time, 200 2 times, 200 3 times, 200 4 times, 200 5 times. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 hundredths. 10 hundredths equals 1,000. So our answer would be 1,000 or 10 hundredths. Let's flip-flop that. I think I have another extra piece here. And we'll say that, so let's do let's do 5 hundredths times 2. So we have 5 hundredths, and we're multiplying them by 2. So we have 2 groups of 5 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would equal 1,000, and there is our answer. Time for a challenging word problem about video games. Are we ready? Yes, we are ready, Mr. Leggett. Let's annotate to find out what we know. Francisco played a video game and earned 60 points. For every coin he collected 7 coins. How many points did he earn, not ear, that he collected? For the coins he collected. Do your best. So, let's take a look. What do we know so far? We know that Francisco got 60 points for every coin, and he collected 7 coins. So let's go like this. This is going to represent the coins. 2, 3, 4, 5, 6, and 7. This is what we don't know. So what we do know is that he collected 60 points for every coin. So how do we figure this out? We do 7 times 60, right? 60, 60, 60, 60, 60, 60, 60. 60 plus 60 plus 60 plus 60 plus 60 plus 60 plus 60. Multiplication is just repeated addition. So we would go 7 times 60. That's what it's going to equal. Equals, and we can make this easy on ourselves by going 7 times 6 times 10, which 7 times 6 is what? Use your multiplication chart if you need to. 7 times 6 is 42. So now it's just 42 times 10. Hey, guess what that equals? 420. He earned 420 points playing the game. But wait, there's more. Francisco continues on. Let's see what happens. Francisco also earned 200 points for every level he completed in the game. He completed 7 levels. How many points did he earn, not die, did he earn for the levels that he completed? Do your best. Okay, so let's take a look at how many points he earned for this. There's 7 levels, right? So we're going to make a tape diagram that's just like our other one. 1, 2, 3, 4, 5, 6, and 7. We know that he collects 200 points for every level. What we don't know is the total. That is what has us bamboozled. So how do we figure this out? This is going to equal 7 times 200, which equals 7 times 2, right? Times what? 100. Which would just equal 7 times 2. Use your chart if you need to, but you can go 2, 4, 6, 8, 10, 12, 14. So 14 times 100 just equals 14 hundredths, or 1,400. So he earned 1,400 points for completing 7 levels. So now, our last thing we need to do. What was the total number of points that Francisco earned playing the video game? Well, so we just take our first answer, which was 420, and we add it on to 1,400. So let's do that. 1,400, or 1,400, plus 420. Go ahead and do the math. Francisco earned points. All right, go for it. You can pause while you figure that one out, and then I'm going to continue on. We have another word problem to do. At a concert, this one's going to be kind of tricky. At a concert, there were 5,000 people in the audience, okay? That was 1,000 times the number of performers. How many performers were at the concert? Do your best. So, let's take a look at this. 5,000 people in the audience. Well, let's go ahead and do 5,000 right here using our place value chart. 1, 2, 3, 4, 5. That's how many people were in the audience. A total of 5,000. Now, if we go back to our question, it says that was 1,000 times the number of performers. So this is the case where we would go backwards, okay? We would say, well, I know that this must be, let's write this down, and we'll say 5,000 equals what we don't know, a question mark, times 1,000. Because there were 1,000 times the number, the people attending were 1,000 times the numbers of performers. Another way of looking at this, we could go 5,000 divided by 1,000. What would that equal? Well, let's find out. We're going to divide by 1,000, so we're going this way. And what's that going to equal? 5. So we say there were 5 performers at the concert. Please put this, your completed packet with your name on it, in the blue bin. And then log on to Zern.